Hi everyone, I'm Julia from Krannich Solar. Thanks for joining our webinar today with GoodWe. Before we get started, I'm just going to be giving a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 23 different countries with the capability to ship to over 100 countries. Krannich Solar has been a strong partner to PV installers since 1995 and offers everything that is required to begin and finish your solar installation. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as GoodWe, to secure the best pricing and availability. With a growing market share, Krannich Solar is a privately owned and self-financed company that ranks among the leading solar wholesalers worldwide. Our experience in delivering solar products worldwide for the last 26 years has made us experts in our field. In 2005, Krannich expanded into the US, with our US headquarters in New Jersey. We also have branches in California, Florida, and we are expanding into Texas, with additional warehouses across the nation. We are growing every day, so keep an eye out for where we're going to be next. Our US team consists of over 80 employees that service the Americas and strives to offer the best services and options to our partners. Throughout the years, we have grown our product portfolio to provide over 5,000 products. We have partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-paneled shingled roof, or a megawatt flat roof. Working with Krannich Solar means you'll never work alone. With our streamlined ordering process, each customer at Krannich receives a dedicated sales rep to walk them through each step of the ordering process, from project design to on-site delivery. The solar industry is always innovating and changing. At Krannich, we do our best to make sure you know what the latest products and technologies are that are available. We team up with industry leaders and seasoned professionals to train you firsthand on everything you need to know, and it'll always be for free. This concludes my portion of the webinar. Here's our contact information if you want to reach out for a quote and if you have any questions regarding the products or services we offer. And if you have any questions throughout the presentation, please feel free to ask them using the question box, and then we're going to be answering them at the end of the presentation. Thank you again for joining us, and now I'm going to be passing it along to Braulio from GoodWe.
Thank you so much, Julia. Hello, everybody. If you bear with me 1 second, I'm going to start presenting in a second. I'll show my screen. Sweet. Let's go. So welcome, everybody. Welcome, and thank you so much for your time in advance. My name is Braulio Escobar. I'm the Director of the Business Development at GoodWe in the US. I manage the Northeast region and also the CNI market. So whatever your reason is for you to join, whether it's for you to assess new solutions out there, learn a little bit about energy storage or string inverters, if you will, whatever your reality is happening at this time, thank you so much for joining. And hopefully your presentation or my presentation today is going to be valuable to you and your business. Again, Braulio Escobar, Director of Business Development. This is my contact information if you want to take a picture. That good looking man is myself. Been in the industry for about 7 years, been in distribution and manufacturing, been in this inverter space for about 5 years already. So happy to be here and happy to shed some knowledge. So I joined GoodWe in the later part of last year. If you don't know who GoodWe is, we're a publicly traded company in the Shanghai Stock Exchange, founded in 2010. The company is based in Suzhou, China, which is kind of like the Silicon Valley near Beijing. One of the things that stands us out is, besides the fact that we're 4,000 employees global, almost a quarter of this amount is dedicated for R&D purposes. So in addition to just manufacturing premium inverters, we also develop and engineer the everything that we're offering. If we were to summarize what GoodWe is, it's quality and innovation. We've been in the US market for about 2 years already. We have our sales, marketing, support, and repair center located in the US. Our repair centers are located in Denver, Colorado. We have a capacity for the US market of production of about 1,000 inverters per month. So we have not been affected by supply chains, so that has given us an opportunity to work closer with some of the U.S. contractors. And that's only not about availability. I think one thing that you might consider too is the quality that comes with it. So we have consistently been ranked as a top manufacturer over the years. We've been awarded the All Quality Awards, All Quality Matters Award 5 years in a row by TÜV Rheinland, which is one of the independent European laboratories. And that just says a lot about the quality. It's not only about one product class, it's about everything that we have. In addition to that, we've seen a lot of growth over the last couple of years. As of 2021, we made it to number 5 as an inverter manufacturer globally. Out of everybody that is in this list, we are the ones that have grown the fastest, and we continue to do so. And that's mainly because of the partnerships that we have secured over the years, and it's the quality and the bankability that comes with it. One more thing to add to this is if for relevance in the U.S. market, it's also the partnership with GE. So GE wanted to enter the U.S. market for residential and commercial, and when they were assessing all the technologies that are out there, they evaluate about 30 plus manufacturers all over the world for inverters. And some of the key criteria was the bankability of the company, of course, the quality, the reputation, and most importantly, the reliability of the product. And we came out on top. So we are an exclusive license dealer for GE solar products. So you will be seeing that a little bit later in my presentation. But in addition to offering GoodWe's products, we also have the GE label products. So very excited to talk about that today. One more thing to add is that besides just offering string inverters, we are also energy storage supplier, and we became the world's #1 storage inverter supplier as of last year. So it's very exciting to be participating in this space, and I'm sure there's a lot of buzzwords, there's a lot of excitement for it in the US, and we have a lot to offer at a competitive manner. So forgot to say, but there's I want to establish some house rules, so I want to keep everybody engaged. So I will be throwing out poll questions, giving you guys a minute to answer. So starting off with my first question for today is, what is your main criteria when choosing an inverter solution for your projects? So I'm going to throw out this question to you guys. I'll give you guys a minute to answer, and we'll review the answers together. I'm gonna give you guys a couple more seconds. We got about a few more people to answer, but we're almost done here. All right, closing the poll now. I'm gonna share the results. As you can see, there's a clear tendency towards reliability and ease of installation. Reliability is key. It is the key principle to which your business is built on top of. Without having a reliable PV system, everything else falls. So that could be your customer satisfaction rate. It can be the cost of your company. It can mean a lot to you. And having a reliable system is essential for any installation. So right on point for major points to everybody. But it's also important to talk about integration of energy storage and for new and existing systems. I think that, as I was saying before, there's a lot of buzzwords there, and I think plug-and-play solutions in this realm is quite important. So appreciate everybody's answers. I'm going to close this off and continue with presentation. So for those that have been in the industry for quite some time, you can remember what it was to install PV systems. Solar panels at the time had a power class of 200 or the low 200s. The inverters at the same time had a very incredibly high startup voltage. So At the moment, you had to install about 14 panels at the time just for the inverter to be functional. The power classes were very low, so you had to install multiple of them for a commercial system. Many components had to be quoted just to have a functional system with communications, and shady losses was almost assumed. There was no technology that helped towards the mitigation of it. So in summary, there was little flexibility, there was a lot of complexity on installations, and the cost per watt was over the roof. I mean, if you can remember, it was near the $10 per watt in the early 2010s, and we've come a long way. But that also opened opportunities for some other players to come in and take up some of that market share. And we've been seeing that it's mainly composed of a couple of manufacturers who I'm not going to be talking about, but they have identified some of the market gaps that we're seeing at the time, mainly in the fields of ease of design. Module level monitoring is a key selling aspect. Also, the increased flexibility. You don't have to think about how many of these components you have to put on the roof. You can just slap and play, if you will. So the plug and play solutions just took over, and now we see a skewed market share for these two people. So that doesn't necessarily mean that it's a good thing. I think there's also there's gaps that were left behind in the sense of reduced cost of ownership. We think that having a costly PV system with relatively unreliable hardware does not answer the question in full. Module level monitoring can also act as a double-edged sword. Too much information to the end user can be also daunting. Too many calls on the tech support line. And last but not least, the plug and play solutions mostly applies in the energy storage fields. It can get quite complex to talk about this, and especially in the sense of cost for energy storage with these solutions. There's better ways to approach it. So we've come a long way in terms of string inverters. This is the current offers that we have. We have solutions for the PV and energy storage field. At the same time, we also have solutions for the C&I market, which I'll be covering as well. And excited to talk about the next generation as well. So if you stick around, you're going to learn about what's coming out in the next quarter. Just a lot of innovation happening. Before I start off, maybe some people are not fully acquainted into some of the main concept for energy storage. So I just want to fly through it and continue on with product-related presentation. So energy storage versus AC coupling versus DC coupling. So let's say you start off with a PV array that's connected to a PV inverter, normal grid-tied PV inverter. In order for you to AC couple, you need to be connected in the same AC bus with a battery inverter that's going to be doing the charging and the discharging. So you will essentially need two different inverters for an AC coupled system. As opposed to a DC coupled system, you're going to have a hybrid inverter that's going to be doing both. It can do the PV side of things, and it can do the charging and the discharging with a battery. So in that sense, what happens here is that you're reducing components and you're reducing costs if you're going to be doing a DC coupled system. However, there's also a lot of some installers that I've been working with are coming back to their existing customer base, and they're trying to talk them into pairing their PV system with a battery. And in order to do so without having to take off the inverter that is already on site, you can add that battery inverter. So both of these scenarios are possible, and they're quite popular in the industry. So when we're talking about coupling, you can do AC or DC coupling, which can be talked as a retrofit or new DC coupled systems. And in backup situations, there's two ways to approach it, whether and this is wholly dependent on what the end user wants to accomplish. So if the end user wants to get essential or critical loads, you are going to do it through a partial backup. And for full home backup, most of the time you're going to be doing it through a DC coupled system. So that's why you see the red boxes, but you can mix and match. You can do an AC coupled full home backup, or you can do a DC coupled partial backup. It just depends on what the budget is and what the main objectives are. But from my experience, mostly for partial backup, you're going to do a retrofit, and for full backup, you're going to do a DC coupled system. However, there's also ways in which you can approach it, and most of this is through applications, whether you want to do self-consumption, in which you're mostly trying to get away from the grid and try to consume as much from your PV and from the battery and not from the grid as much as you can. You can also do that for partial and full backup for people that are in endangered areas where they can be affected by nature, if you will, by hurricanes and any other things. Like in California, it can be the wind season or fire season, if you will. Public safety power shutoff is a big thing in that area. And lastly, and this is probably specific to California, time of use, which is energy arbitrage, doesn't really apply in many other states, if any. But energy arbitrage is basically consuming from the battery in peak hours during the day, and you're going to be paying a lot less on electricity. But more to come on that front at a nationwide scale. Second question of the presentation. So my question here is, which application of these is the most common that you're seeing in your solar energy storage installations? So I'm going to launch this second question and continue on. Give you like 10 more seconds to finish this off. Okay, thank you very much. As you guys can see, there's the majority of the time is for partial home backup or critical loads. And the reality is that its budget is what affects it. Doing whole home backup can be quite expensive, and it can be quite complex as well. So the safer bet is probably the partial home backup. Unfortunately, we have a great solution for that today that I will be talking about in the next couple of slides. So I appreciate everybody's response. Very engaging audience today. So continue on. With no further ado, want to introduce our residential product overview that is available today. So we have 3 different iterations. We have the PV only solution, just grid tied, no batteries. That's the AMS series. We have for AC coupled or retrofits, we have the ABP series, and the all-in-one solution, our full hybrid flagship inverter, is the AES series. As you can tell, the chassis, the feel, the looks is pretty much the same. It's the same components, but you will notice that there's very small differences between them. On the AMS side of things, you have the AC disconnect on the left. The ABP series doesn't have any disconnects, but there's a dry contact and integrated into the inverter. And lastly, for the hybrid inverter, there's the AC disconnect, and then you also have the AC bypass. And the bypass is going to be used in scenarios where you want to pair up a generator or an alternative backup solution. It's not automated; it's a manual switch. So, as a fun fact here is that GoodWe's started in the U.S. market with a hybrid inverter, and over time we realized that there was also value in the grid-tied sector. So the backup or the battery capabilities were taking off without compromising the grid-tied side of things. So when we're talking about the PV design flexibility, it's basically for both the AMS and the AES. So the power classes, we have 7 different iterations that ranges from 5 to 9.6 kW. The startup voltage range is quite low, 80 volts for the lower classes and 95 volts for the larger classes. There's 2 MPPTs on the smaller sizes, which is the 5 and 6, and then anything above 6 is 4 MPPTs. If you understand what the concept of a MPPT is, it's basically inverters within an inverter. So I'll be talking about the major advantages of having more MPPTs within the same inverter. The arc fault detection is included. And then for plug and play rapid shutdown requirements, all of these inverters will be coming with an option of either Tigo or AP Smart. As a matter of fact, I believe most of what Krannich has available today is AP Smart. So that's how you're going to be quoting your systems. The DC ratio in essence is 1.5, but for the 9.6 kW as an exception, you can put up to 15 kW in DC on this on that inverter. And another thing to point out here is that the hybrid AES inverter can do all the PV stuff without compromise. So without a battery, it'll still output you 9.6. In backup mode, it will still output 9.6 kW. So there's no derating on this inverter. Some of the common features here is that every inverter comes with an integrated smart meter for consumption monitoring. It comes with the CTs on the box with the calibrated string. It's about 30 feet, if I'm not mistaken. So they're calibrated. So that means that I do not recommend you guys cutting the string. It is calibrated to that length. The Wi-Fi communications module is included in the box. It's very important to keep it because this is the device that you're going to use to commission the inverter with your smartphone. Out of the box, every inverter comes out with a 10-year standard warranty, and you have the option to extend it from 15 to 20 years. Then there's other features that I want to talk about at the installation level. So this is where the magic happens. Essentially, you don't touch anything that is on top of the wiring box. So you can, in a given solar array, you can put either 2 or up to 4 strings coming into the left knockout. These are pre-drilled knockouts, but they're not really knockouts. Like they're kind of like screwed in together. In the middle, you're gonna see a Wi-Fi module. We call it the Wi-Fi dongle. And then on the right side, that's where everything comes out AC. And then connect to the main service panel. The amperage voltage can range between 30 to 50 amps. It just depends on the size of the inverter. But it's just very simple to install. That's the whole point of this slide. Some of the other major advantages, and as I was talking about the MPPTs, the reason why this is such a high feature for us is that we can attack very complex roofs. So you're looking at a house that has multiple orientations, that has different shading scenarios. Having 4 MPPTs in an inverter can allow you to tackle these applications where each string is going to be independently working from another. So if there is shading, or if there's something on a side of the roof that is that's not allowing the modules to perform just as well. For example, if there's an array up here, this one is going to be independently working from one another. So the major advantage is that you get more production, you get more flexibility with less components. 150% oversizing. This is mostly important when you're trying to compensate for shading loss. In that scenario, the starter voltage of 95 volts allows you to put in with a minimum of today's modules is probably 3 of these to get the inverter started, up to 600 volts. Right now the modules are somewhere around the low teens, so between 10 11 amps. So we can still tackle most of today's you can still use today's modules, but we understand that PV modules are growing in power every single year. And in order to compensate for that, the current is increasing every year. So that's going to pose a challenge to inverter manufacturers. Reminder, we have the Tigo ability or AP Smart compatibility. So with whichever rapid shutdown device you want to use, we can do either. However, I don't recommend you guys to mix and match. If you're going to have a Tigo rapid shutdown transmitter, pair it up with a Tigo receiver, and same thing goes for AP Smart. This is a typical flow of how our AMS looks like. We strongly believe in the SunSpec Alliance, just plug and play solutions. So rapid shutdown happening at the module level, but it can be also in a 2-to-1 configuration. because Tigo and AP Smart both offer a bi-modular rapid shutdown device. Communicates with the inverter via the transmitter. It's connected to our SEMS monitoring portal via the cloud. Our servers are in the US if you want to ask that later. And lastly, the PV Master app, that's where you're going to do most of the monitoring, remote configurations, remote firmware pushing, anything that you want to do as far as reporting, setting up alarms, etc. All right, so last question for today will be, what is your energy storage attachment? Your attachment rate? It's just quite important to see in practice actually how much energy storage you guys are working on. Some states, if you will, like California, ranges between 10 to 25%. Maybe you specialize more in energy storage, or you're seeing a lot more demand to it. Just curious to see where you guys at in terms of that. I just want to feel the floor. All right, cool. I'm gonna close this out and share with everybody. As you can see, the vast majority of people are doing 10% or less. We think that that's kind of goes in line with what's going on at an industry level. It's gonna continue to grow, but for those that are doing more than 10%, yeah, I mean, there's definitely some intrinsic challenges on that, and definitely want to hear what you're seeing in your market. So hopefully we can connect after this presentation. But moving on. So I want to talk about our current energy storage solutions and their applications. Just a fresh refresher, we have the ABP series for retrofits and the AES series for DC coupled system. So these are some of the applications that you will be seeing. I was asking about self-consumption. For those that are doing it, it's the simplest way to work around having batteries. It's basically people that want to avoid the grid as much as they can. However, in an outage situation, the whole system is going to come down simply because there's no switching. It's just fully connected to the grid. But you will, in that case, you will just pair up an inverter and a battery. Not sure who was going to ask you for that, but there's all sorts of people out there. Same thing goes for AC coupling. In order for you to pair up a battery, you need a battery inverter. So that's a self-consumption system, pretty self-explanatory. The partial home backup. Most of the time, this is what I understood from everybody that's doing partial home backup. So this is kind of a typical scenario of what you'll see. It's a GoodWe's inverter with the auto transformer. The auto transformer is needed in order for it to derive a neutral signal when the grid is out. So when the grid is out, the inverter is going to switch over to the backup essential loads panel. This inverter is UPS level, which means uninterrupted power supply. So what that means is if the household where this inverter is installed is dependent on critical loads, so for example, someone's living off of a respirator and cannot have any power interrupted or else it'll restart. In these scenarios, this inverter is the perfect use for you because it'll do the switching within 10 milliseconds. So that's on a DC coupled system. In an AC coupled system, you will need the same components, just the ABP. And this is mostly for systems where there's already solar. And same thing, it's connected to the backup panel. This is a whole home backup scenario where you're DC coupling. The main difference here is that you have to include a fourth component, which is the auto transfer device. So this device is basically gonna open the circuit from the grid and close the circuit into back and transfer all the loads into backup mode with the main service panel. Yeah, it's fairly simple. In an AC coupled scenario, and this is where it's a little bit more complicated, and I just want to make everybody aware of it, is that you can still do the whole home backup with the ABP. You can still tackle that application, but one thing to notice is that in backup mode, when there's an outage from the grid, if the PV size or the power class of the PV only inverter is higher than the ABPs here. So in essence, if you have a string inverter or have a PV system that is larger than 9.6 kW, you might come with it might be an issue because when it's on backup mode, this PV only inverter is still working. It's still delivering energy to the main panel and transferring it over to the battery inverter. But when there's more energy for the ABP to take, there's nowhere for this energy to go. So all of this energy is dissipated as heat, and in consequence, this can heat up the inverter and damage it long term. So I don't recommend this scenario in a case where you're speccing more when you're speccing a 9.6 ABP with something greater than its power class. It's a little confusing, but if you have any follow-up questions, I'm happy to answer at the end of the presentation. All right, so for those that are still iffy about GoodWe and they have a customer base that are a little bit more sensitive to the branding, don't fret. As I was saying before, we have a great partnership in line. So we have the GE license partnership. We're the exclusive dealers worldwide for this for residential inverters. So what that means is we have the same solution, the same hardware. However, the difference here is the color and the labeling of it. And yeah, with no further ado, just want to introduce what we already have available today. It's the same. It literally is the same solution as I was talking about, the ABP and the AES series. The main difference here is that there's no bypass on the DC coupled solution, so that would be the GEH. There's a dry contact. So what the dry contact is going to do is that it's going to do the switching at an automatic level. So if you have a battery, you have a generator. So the dry contact, what it'll do, it'll change the direction of which it's going to start perceiving the backup. So in a scenario where you have the battery, you have the generator, the battery is running out of juice, and then the dry contact, what it'll do is that it'll open that circuit with the battery and close it in with the generator, so you will have the backup of the backup turned on. But the specs are pretty much the same. You have a 50 amp DC discharge and in charging capability. It's very important to talk about current, especially in the energy storage segment, because it's how much actual power you can put in and charge and discharge and use at a given moment. You compare these up, whether it's a GoodWe or a GE labeled inverter. You compare it up with an LG battery, the Resu Prime, either it's the 10 or 16. You can do 1 or 2 stacks of these, up to 2. You can tackle it for partial and full backup solutions for essential loads. It's also UPS level. And for a whole home, I would just remind you that you need to pair it up with an automatic transfer device. So I want to compare this solution with something that is one of the predominant technologies out there. And I just wanted to point out that the current here is quite important. And it's also how much power you can get at a single moment from a single battery module. So compare this at Resu 16H versus a non-charge IQ battery. As you can see, the current available for the LG battery is a 20 amp nominal. It can give you 7,000 watts at a given moment. And you're very limited with an N-phase IQ battery. You can only output 3.8 kW at a given time. And you need, in order for you to get more of that capacity or the equivalent to LGs, you have to get at least 2 of these battery modules. So it is extremely expensive and extremely heavy. And the constraint here is also, I want to point out that the ABP is not the constraint here. The constraint is the battery. The inverter can output the equivalent of 2 batteries stacked in parallel. So we can output 9.6 kW at a given time, no problem. Same thing goes for the GEC or the GEH. The capacity, the amperage does not change. 40 amps is quite a bit. So that's pretty much it on the energy storage side of things. If you have follow-up questions, we can talk about it at the end of the presentation. But moving on to the C&I segment, for those that are doing commercial, I'm very excited to talk about what we have today. The challenges are different one from another, from residential to commercial. In commercial, it can be anything from lowering costs. It can be how to comply to the rapid shutdown requirements with having the least amount of components. It can be just not having an available product because whoever you're probably using at this time either doesn't have the product or they're expecting to release something else in the coming year, and there's just nothing available for you to use. Fortunately for us, we have a lot of availability of the SNT-US, and it comes in 2 iterations, the 50 and the 60 kW. You can put up to 6, connect up to 6 MPPTs. Each MPPT has a capacity of 30 amps or 15 amps per string. So basically what you can do is you can combine the strings into the same MPPT. There's surge protection included. It's a fuse-free design, so no fusing, which is great. For rapid shutdown requirements, if you're going to be using a receiver at the module level, you would have to pair it up with AP Smart or Tyco, so the rapid shutdown transmitter is already included. There is also the Wi-Fi communications module included out of the box, which is what you're going to use to commission the inverter. It's a fantastic product. It's very competitive, and it's just quite simple to install. I want to put this out there that it's not a new product for us. We've already had multiple iterations of this at a global scale. We have over 100,000 units installed of these at a global scale. We just have the experience in the C&I segment. It's just that we have developed the UL version of these inverters for the US market. On the monitoring side of things, fairly simple. This is kind of like the landing page of what you would see if you were to connect to the SEMS portal. SEMS is the solar energy monitoring solution. So yeah, you can get very granular data if you wish. You can do remote firmware pushing. You can do remote diagnostics. It's a quite intelligent solution. You can also look at the statistics at a channel level. So if what interests you, if you're trying to perform O&M on this and you want to see what the voltage is for a given MPPT, or whatever you want to do at the string level, you can definitely look at that information. It's all available. And if you're interested into having a walkthrough or a demo on the SEMS portal, I would be happy to connect with you at a given time, at a different time. And this is the most exciting part of the presentation. Who doesn't like to talk about new products? So with no further ado, this is our next generation MS-US 30. Some of the numbers that are in green is what really excites me here, is that we will have the largest available string inverter in the market with an 11.4 kW. The DC oversize is going to be up to 160% of its capacity. The MPPT count is going to be lowered down to 3. And the logic behind it is that as the modules continue to become more intelligent and more and just more powerful, there's less to optimize, and by that, and the current of it is also increasing. So with that being said, like we can't really facilitate more MPPTs than 3. Starter voltage has been lowered down to 80 volts. The current input is going to be 16 amps, just contemplating that the future is going to bring high-powered modules with higher current capacity. Surge protection is also included, level 3 DC and AC surge protection. That's on the PV grade side of things for GoodWe. We have the same iteration coming out with GE. It's also going to be available with Krannich. It's the same product, just a different color, different label. It's not as dark as it looks. It's actually a little more on the metallic side of things. It's a beautiful product, and it has just the same specs as that of the MS-US. Just putting it out there, that's going to be available soon. Then this is our flagship energy storage hybrid inverter. The ESUS has the same PV capabilities as the MSUS. We'll have an 11.4 hybrid inverter. My favorite thing about this inverter is the discharge power, that you can discharge 105% of its nameplate. And the reason being is that when you're transferring DC to AC, there's obviously an efficiency loss. The efficiency level of this inverter is 97%. So if you're outputting 105% of its nameplate, you're compensated for the loss. And so you're putting 100% of what the inverter is supposed to be giving you. In the case of the ESUS, actually the MPPT count has not been compromised. You can get iterations of 4 MPPTs, and that's only going to be available for the larger power classes. So from 7.7 up to 11.4, that's where you're going to get the 4 MPPT counts. Anything less than that, it's the 5 and 6. It's going to be 2 MPPTs. Same thing with startup voltage and the current input. Same thing as the MSUS, surge protection as well. And one thing that is really nice about this inverter is that, say for example, you're sizing 150% of the nameplate of this inverter. So you have an 11.4 kW system, and you're putting 50% of its capacity. That's give or take about 17 kW. So in a moment where the household is using 11.4 kW and there's still more energy being outputted by the solar panels, that residual energy is not going to be dissipated as heat or unused. As a matter of fact, that energy is going to be transferred into the batteries to charge the batteries. So there's no loss of energy here. Most of what the panels are producing is going to be used up, which is amazing. It's amazing. We also have the SBP series, which it has the same battery capabilities of the ESUS. Obviously, it doesn't have the PV capabilities, but it's the chassis, the look of it is the same. It's just that the PV component is taken off. This technology is made for it to do designed for full backup capabilities. So we have also developed two different transfer switches. We have the ABD, the automatic backup device, and then we have the the MPD, which is the multi-inverter parallel device. That's for when you're trying to stack more than 2 inverters in a single box. We also will have an EV charging option rated at 9.6 level 2. And the best thing of all is we've gotten rid of the auto transformer, so the neutral is going to be derived by this inverter, so less components to think about. In addition to our inverters, we're also coming out with our own battery called the Lynx FHUS. It's a stackable solution. Its rated output power is 13.4 nominal with 35 amps, which is really, really good. You can stack up to 6 of these modules and put up to 2 towers per inverter. These are some of the applications that you will see, and I was showing them earlier, but there's some differences here that you don't have the auto transformer included into this inverter. So in an AC coupled solution, you have the Lynx battery, the SBP US, an EV charging option, and the automatic backup device. That's for this is a whole home backup situation. And the same logic that I was talking about, like how much solar you can put, how much solar can be connected to the SBP. Same logic of if you have more than 11.4 kW, please don't use this technology simply because of the energy dissipation that might just damage the inverter. But it's still a very exciting solution. This is a whole home backup and generator solution. So this inverter also comes with a dry contact, so it'll communicate with most of the popular generators that exist today. You will have the EV charging capability, and then you would be backing it up with an automatic backup device for a whole home backup situation. A very robust PV system. And this is one of the crazier configurations that you will see out there, but it's possible. There's a lot of people that are just believing in the end of the world, and they want to install as much PV and energy storage as they can and live off of that. So for those that are looking of that level of robustness, it is possible. So all of the 3 inverters are going to be stacked into the multi-inverter parallel device, and each inverter can be stacked with 2 towers. Yeah, it's a very robust system. So it's also coming soon. It's going to be available in the next quarter. I want to end with a positive note on this side of things. So storage is supposed to be complex. I pulled this picture out of this manufacturer's website. Of course, they're trying to sell the fact that it's a clean design, which looks clean. It's a clean installation. However, it's 5 boxes. Like, not that many people have that much space in a garage for 5 boxes. So it's supposed to be simpler. It's supposed to be cleaner. So if we're going to compare it to this technology, and we also outperform here in a given time, we can provide twice as much power than an Enphase IQ battery at a given time. Yeah, so the inverter having a 50 amp charge and discharge capacity, 50 amps is not the constraint here. We can pull as much power as we can from the battery. So it's just very robust. And we can compare against another big competitor, which is Tesla, and we can produce as much as 1.75 times more power than the Tesla battery. And the bigger constraint here is the current capacity of the battery. So having a 35 amp capacity and stacking up to 2 of these stacks for 70 amps, in that case, the inverter obviously will be the constraint, but 50 amps is quite a bit of power anyways. So we've reached the end of the product side of things. Just a couple of things that I want to summarize this with. Why should you consider GoodWe or GE? I went from the beginning of the slide. I was referencing to the topology of string inverters, and the fact is that they're known to be more reliable and need less components for it to be functional. So when you're reducing components in a PV system, you're increasing the reliability because you're getting rid of points of connections, and points of connection, if you do the math, they are actually the biggest cause of PV failure. So the less components, higher reliability. And you've seen that we have it all for all sorts of projects, whether it's a residential, commercial, or energy storage project. We can offer all of this under the same roof. For those that would have a little bit of a challenge selling a GoodWe's system, don't fret. We have the GE label product available as well to you. It's as everybody knows, you can reference easily to GE. You can easily point to a refrigerator. You can point to any of the electrodomestics in the house, and the homeowner is going to feel a little more comfortable talking about that. I think these last 2 descriptions, affordable and available, is right now that is king. As I said before, we have a high production capability of 1,000 inverters per month dedicated to the US market. So lead times is not a problem to us. We have a lot of available products today. Krannich has a lot of available products as well. We're just eager to support your business at competitive prices. So once you're sold on a GoodWe or GE system, I would highly recommend you guys to schedule a training with us. It's only an hour of your time, but this hour is going to be very impactful for you, because during the quick start training, we're going to be going over the main steps that you need to take in order for you to successfully install your first inverter. And so giving you guys the steps and what you can expect on your first installation is going to reduce the likelihood of you calling the service line because of any missteps that might have been taken, and you're going to also reduce the likelihood of having a truck roll because something was not done properly on site. So yeah, so it's a simple 1 hour course. It's going to be scheduled at your convenience. You schedule it whenever you want, and you're going to be the exclusive audience. So there's not going to be a competitor. There's not going to be anyone else but anybody else but your company is going to be there. So you can ask all the questions. You can dive deep as much as you can with confidence. And so once you finish this training, you will receive a code to complete the commissioning in our online portal. So this code is going to be your customer ID, and that's what you're going to use to commission your fleet going forward. So that's how we're going to be keeping track of you, and that's what you're going to use in order to log into our portal. So with that being said, we've reached the end of the presentation. I probably went a little bit over the hour, but I appreciate everybody's time. I will give you guys a few minutes to ask any questions. It can be product related, or it can be, GoodWe's related, or you can ask me anything. So thanks again for your time.
Sweet. Thank you so much, Braulio. That was a great presentation. We have a couple questions that already came in. First, we were actually asked how many attendees we had today, which we had 30 people in attendance. So thank you everybody for joining and staying with us. And then next we have on here for you, somebody said that Tesla and others went from DC to AC to gain initial market share. And they asked if DC coupling requires too much site-by-site engineering.
So from to AC, DC to AC to get my initial market share, DC coupling requires too much site. Well, I guess, Drew, to answer your questions, if you have access to these Tesla batteries, you're right. There's less engineering, and the Tesla is more inverter agnostic. You can pair it up without solar if you wanted to. The real challenge is, can you really get availability of this battery? So, if you have challenges on the design side of things for DC coupled systems, happy to have a look. But if your concern is on AC coupled systems, of course, there's the challenge of putting more components, but it really all just comes down to how much you can get of these Tesla batteries, because we know it's no secret that they're hard to come by.
And then next, we were asked, can the inverter be stacked or paralleled together?
Yes, they can. You can stack two inverters together, and yeah, it's going to be available by the time you start buying energy storage systems. I think right now there's a pause on that, but we know that in June it's going to be it's totally possible. So you can parallel them, yes, up to two of these. And then for the next generation of products for the ESUS, if you're going to be stacking them together, just a reminder that if you're doing 3 of these, you have to spec them with a multi-inverter parallel device. If you're doing 2 inverters, the ABD or the automatic backup device can solve the problem. For the current generation, you can do it the ATD today.
So if the PV system is larger than the 9.6 kilowatt, could you have multiple inverters? And would each inverter require its own ATF? If there is a situation where multiple inverters or larger PV can be utilized, and then what equipment would need to be in multiples?
Yeah, it's a big question, but I guess hopefully the previous question you answered the question. But the main challenge on an AC coupled system in that scenario is that the PV grid side inverter and the multiple inverters, say for example an AC coupled inverter, if you put them together in a whole home backup situation, they're going to be competing against each other. The signal will be competing against each other. So we haven't, quite frankly, we still haven't tested that for a whole home backup situation, because the architecture of the ABP was not made for a whole home backup situation with multiple inverters in a retrofit. But if you have projects like that, let's take it offline. I'd be happy to help you out. But it's a great question, Tim.
Great. Then we were asked, what batteries are the inverters compatible with?
Sure. So today, the ABP and the AES series, which is the current generation that we have, is compatible with the LG Chem, the ResU10 and ResU16H, and then the BYD battery, the HVL, and that's, as of today, what we're UL 9540 compatible with. I'm not sure where you are located, Aristotle, but I guess with that being said, it's just for the, that's for the current generation. For the next gen, the ESUS and the SBPUS, they're compatible with their own batteries. So I would recommend you to pair it up with those. The price difference, well, I guess Drew made a question, price difference between 5 and 11.4. Well, I will have your sales rep to answer that question for you, but they're quite competitive, price competitive. Kathy Sims asked a question about what is the total cost of a retrofit with a 10 kW system for the various size batteries that are currently available. Kathy, if you want to run this scenario with me offline, happy to do that. But yeah, price at the end of the day is going to be discussed by your sales rep at Krannich. But I can help you spec a bill of materials for this scenario. Will EV cars work as a battery? Great question, Dwayne. At the moment, we haven't tested that. We're not UL 9540, so if you were to pair it up with a, say, like a Ford F-150 Lightning, it's not possible as of today. We just don't have that certification. I'm sure it's gonna be a thing. We just haven't tested it yet. And I guess the last question from Quisha. Does Krannich Solar have the GW35K LB MT inverters in stock? This model was replaced by the, I guess you said the same thing, the KLS, the KLB versus the KLS. So no, as a matter of fact, the US market only has available the SMT series, which is the 50 and the 60. We don't have a 35 kW inverter available today for the US market, unfortunately.
That seems to be, oh, we got another question coming in actually. Is the EV charger compatible with the ES-US20 inverter?
Yes, it is. It comes with EV charging capabilities. So you can compare it up with a level 2 EV charger. So there's a lot of brand agnostic EV chargers, and I just don't want to name the few, but we definitely are competitive with the agnostic ones. And I want to say starting next year, we're going to come out with our own EV charger that you can print up with the ES-US.
Awesome. So that seems to be all the questions we have for today. Please, if anybody had any more questions, don't hesitate to reach out. And thanks again for joining our webinar, and thank you, Braulio, for being such a good presenter.
Thank you so much, Julia. I appreciate everybody's time. And then, yes, you have my contact information on the slide today. Just reach out if you need anything. Otherwise, I'll be following up with you offline. But other than that, thank you so much for everybody's time, and we'll be talking soon.